is the story of how a Casio mini calculator led directly to the formation of the software giant Microsoft. So you can see this is a calculator from 1972, and I'm sure this is going to be hopefully news to most of you as to exactly how this happened. So since the turn of the 20th century, people use mechanical calculators like this one to do their science and accounting problems. And you would have this on your desk, and you would add your accounting up. You can see it obviously doesn't have a lot of advanced technology and science functions, but this is what you would have seen in the World War II era. And over time, things got a little bit more advanced. Still mechanical and electrical. But here's a Monroe 8F213 from around 1964, 1965. And you can see there's a lot more places that you can do your math, a lot more precision, but still mechanical. Here's another one. This is a Commodore mini calculator. It's all still mechanical. The readout is on paper. But around 1967, that's when electronic calculators, first using vacuum tubes and transistors, appeared. At the time, these machines were called desktop computers, as you can see. Now, would you have believed that before? But there you go. 1967 May, you see the term desktop computer. So when you look at history, if you put it in today's context, you're making a mistake. You want to look at history from the perspective of the time, not of today's time. And back then, computers had a different meaning and a different word as far as, it was related. Obviously, people know about the term computers referring to women who used to do the math during World War II. Those were computers. So over time, this terminology has evolved. But in 1967, you've got desktop computers are essentially fancy electronic calculators that can maybe do basic rudimentary functions like square root. But the display is in a Nixie tube or other type of actual electronic display. This is a picture here of the first desktop computer, if you want to call it that. Of course, we today would call this just a gigantic calculator. The first one, this is the Model 132 from Frieden, who made the Flexo writer and eventually got bought out by Singer, that could perform a square root calculation. Uses germanium transistors, delayed line memory, cathode ray tube for a display. So it's almost sort of like an oscilloscope sending its display out to the monitor. And here's a picture that I took of one. These are all pictures I mostly took of things that I've actually seen myself. But you can see it's really awesome as far as how it looks and working with it. But what it would do is it would actually have memory. It actually had the ability to store a few lines of numbers in memory, and you could actually run computations against something that had been entered in previously. So that's a pretty new thing. And over time, you could see Toshiba, the Japanese, entered the market. You've got the 16-digit displays, Nixie tubes, so you're getting more display. You're starting to become compatible with the most advanced mechanical calculators, which are still being sold at this time. So this one is 1969, and this one would have cost $1,400. But what's important here, really, isn't so much that this particular calculator did anything fancy other than the fact that it's a Japanese calculator. And you're starting to see the Japanese not just make componentry cheaply, but also actually put out their own calculators. And that was in some ways the beginning of the real calculator wars that took flight in the 70s. Here's another one. It's a little bit smaller. This is a Singer calculator from 1971, and it's one of the final desktop calculator footprints. This would have been about the size of the weight of a phone book. So when you're selling this to somebody, you would say, "Oh, this is only as heavy as a phone book." And obviously today that sounds funny, but back then this was cutting edge. Then all of a sudden, Casio came out with this little itty-bitty calculator. This is 1972 August, and the Casio Mini was the first handheld calculator. Over 2 million of these things were sold, and guess how much they cost? $99. So you could see this was a huge impact in the market, and of course it's going to have ripples. And okay, I'm setting you up. What's the connection between Microsoft fit in your pocket. It was smaller than a pocket camera. You can see back here you've got 4 AA batteries that you could use to power the thing. Significant improvement. So the Japanese had really come up with something remarkable. And there's the manual. Just like a manual you'd get for a watch today, you just don't read it. Why? You turn it on, you use it. You don't need to know how to use it. You don't have to learn how to program it. You turn on the calculator and you just use it. Other manufacturers, of course, had to follow suit. On the left, for me anyway, you see the Casio, the Commodore, which earlier you saw that desktop unit. They got smart. They got the money. They made a small version. Texas Instruments, of course, many of you are probably familiar with that calculator. When I was a kid, I remember we got a calculator. Somebody down the street got one of these calculators, and everyone went to the house and looked at it, and I remember wanting to touch the divide button, and the guy's like, no, I don't know what that does yet. It was, you have to understand the times were different, and I remember actually getting in trouble for wanting to divide something. But not everybody was on board, and there were still manufacturers. 2 months before the Casio Mini came out, in June of 1972, a little company called Micro Instrumentation and Telemetry Systems announced their new calculator, KIT, right into the highly competitive desktop calculator market. This is an image from the July 1973 Radio Electronics article, and Ed Roberts is the name of the guy that ran this company. And here's a couple of pictures from the Radio Electronics magazine, geared towards hobbyists, geared towards people who want to build the calculator themselves. It was less expensive than $1,400. You could get this thing for $250, but you had to build it yourself. You had to enter in the ROMs, you had to solder it, you had to put the wires together, you had to do all the work yourself. This thing had bridge rectifiers, you can see caps and resistors and so on. So you have a whole schematic that you'd be working from, and this is actually a selling point that you would actually get to do all this. And you can see the input consists of an array of switches housed in a keyboard, and closing one of the switches causes a start signal to be generated in unit response. And here's a picture of the one that I have, and you can see the complicated wiring, and this is actually a friend of mine was working on this, Bob was working on this to fix it and replace one of the ROMs by building his own PIC chip to replace one of the ROMs. But you can just see that this is definitely not a pocket calculator. And there's the final product. Very good. Okay, so the kit sold for $200, or you could buy it assembled for $250. You compare that to the Casio, $99, and within no time at all, Ed Roberts found his company MITS was $300,000 in debt. So Ed decided to take the lesson of Casio and apply it to the new idea that he'd been playing with. He knew that his 1440 calculator could be upgraded to accept up to 256 instructions. Why not make a computer? So he didn't go the make a little kind of calculator route. He went make a computer route. He knew that in the early 70s he knew that in his time, the early 70s, useful mini computers were simply too expensive for the average person, but he knew that everybody wanted one. He knew that there was a potential demand, and so he said, what the heck, let's do it. So he called up his friend in Popular Electronics, and the MITS Altair 880 was born. So he told them at the time he had a computer for them. They were thrilled to feature this. They gave him free press. They gave him a free cover. And there was a 2-part feature, one in January of 1975, and the next was in February of 1975. The Altair was sold only to, early in 1975, was extremely primitive for today's standards. And it ran at a minute fraction of today's processor speed. Here's a picture of it. It's about 7 inches by 20 inches. The only way to interface with this thing, though, it was a computer, but you couldn't do anything with it. It had some front panel switches. It had some lights. You could turn it on, but you weren't going to play Pong with it, which was a very popular game at the time. You weren't going to interface it, do word processing. You weren't going to write with it. You were going to barely be able to do machine language programming. And the only way that you could actually interface with this would be to write your own programs with a teletype punch them to tape, and write your own assembler and write your own compiler and all of that. And if you were into that kind of thing, and I assume that Ed Roberts of MITS figured his calculator-making guys would use their new handheld calculators to do the calculations they needed to then create this computer, I suppose. But at least this really kicked off a revolution, but there was a problem. It wasn't really very easy to use, and it wasn't really ready to be mass-produced, and it wasn't really for mass market. So the call went out to put together a BASIC. As you know, BASIC would be the holy grail, I suppose, for what eventually became the way that computers would operate. It would be the thing that would make you go better and faster and mass produce and general public access to a computer. Because with BASIC, you could do both calculator functions and so much more. You could write programs, and you could do those kinds of things that people were doing with time-sharing computers and mini computers in the early 70s. So Paul Allen and Bill Gates were both from Seattle, but they were going to Harvard at the time in 1975. And when they learned about the Altair from Popular Electronics article, they decided to make a BASIC for it in 4K, leaving space for programs. Here's a picture of what they looked like back then. Bill Gates and Paul Allen called Ed Roberts about hiring them to make Altair BASIC. Paul flew to Albuquerque with a paper tape containing BASIC on it. Paul Allen and Bill Gates got a contract to make BASIC for the MITS, and Microsoft was born. And you can see a quote there. Ed Roberts, we'll give the first guy that shows up with one. We'll buy the first guy that shows up with one. So basically, they took them up on it, and that's how Microsoft was created. Here's an ASR 33 teletype. Bill Gates and Paul Allen's first commercial software was Microsoft BASIC, which was originally distributed on paper tape for use on this kind of a teletype. The teletype was the I/O device employed by the MITS Altair, and that's how it would have been delivered. So you would have bought your Altair, you would have built it, and then you would have sent away from MITS, and you got a little paper tape that you would be able to load. 20 minutes later, you'd have a ready prompt on your computer. And just so you know, I do have my original software license for the paper tape software. So nobody can say that I've been ripping them off. And there's the logo. So Microsoft did not invent BASIC or the personal computer, but they were among the first to look at the PC software as a product to be sold and supported and not simply given away for free with the computer. This was very controversial at the time. You could also say that software piracy owes its foundation to the Altair as well. And although I'm sure it would have been simply happened some other way, computers would have eventually come. The Casio Mini, which helped spur MITS to make the Altair, also therefore holds a special connection to Microsoft as well. It's for you to decide.